about second unit in highway and railway engineering. In this unit, we are going to cover cross-sectional elements, horizontal curves, superelevation, transition curves, widening of curves, side distance, vertical curves, gradients, pavement components and their roles and design practice of flexible and rigid pavements. Introduction to this unit. It is mentionedly may basically align the center line of the highway on the ground is called an alignment, in which it includes horizontal alignment as well as the vertical alignment. Horizontal alignment is nothing but a straight and curved path, the deviations and horizontal curves. Vertical vertical alignment includes changes in levels, gradients and vertical curves. These are all the requirements for a ideal alignment are short, easy, safe and economical. It should be short and safe, and that is told in the short alignment. And the next one is easy. It should be easy to construct and maintain. The operation of the vehicle and the maximum indent should be BR provided. And it should be safe both from the construction and the operating point of view, and it should also be economical. The factors controlling alignments are obligatory points, traffic, geometric design, and economics and other considerations. Obligatory points are the main points that governs the highway alignments, which includes points through which the alignment should pass and through which the alignment should not pass. It should passes the bridge side, mountain, construct a tunnel or to the around the hills, and which should not pass through our religious places and very costly structures, lakes and ponds. Traffic, it should suit the traffic requirements, and in the geometric design we are telling about the gradient and radius of curves, side distance, etc. Economics, it should be highly economical to the construction, maintenance, operating cost, and it should be also in a minimum way. And then other considerations are climatic factors, political considerations. An engineering survey of highway alignment. Before constructing a highway alignment, we should consider these 4 points or map study, reconnaissance survey, preliminary survey, final location and detailed surveys. Preliminary surveys of the pre surveys that should be conducted before constructing it. Those are topographic, drainage and SOG to compare the different proposal in view of requirements of a good alignment. The preliminary survey may be carried out of the following: conventional approach, rapid approach and modern techniques. Preliminary survey. Preliminary survey includes the follow steps, which means primary transfers, topographical features, leveling work, drainage studies, soil survey, material survey and traffic study. Final location and detailed survey on the first the location should be designed, and then it's establishing to the central line, and the informations are collected and prepared and planned should be given to the project. Detailed survey. In this, the temporary benchmarks are fixed and the leveling work, drainage details, everything should be covered in the detailed surveys. And topographic details should be noted on, and detailed survey should be carried out enabling drawing of soil profile, CBR values, and then the data during the detailed survey should be elaborate, preparing detailed plans, design and estimate of the project. Steps in a new project work are map study, reconnaissance survey, preliminary survey, location of a final alignment, detailed survey, material survey, design, earthwork, pavement construction, construction planning and programming. What is meant by a transition curve? It is a curve of variable radius is known as transition curve. Transition curve is a curve in plane which is provided to change the horizontal alignment from straight to circular curve gradually, means the radius of transition curve varies between infinity r to r to infinity. Yeah, as soon as the vehicle commences on a motion, it should be subjected to sudden centrifugal force, which not only causes discomfort to the passengers but also shortens track alignment and stability to the rolling stock. In order to smoothen the shift from the straight line to the curve, and the transition curves are provided on either side of the circular curve or the centrifugal force. Transition curve is therefore the curve of an uncomfortable ride in which the degree of curvature and the gain of superelevation are uniform throughout its length. The following are the objectives of transition curves, which is transition curve, circular curve, and then transition curve. It means the circular to decrease the radius of the curvature gradually in an opened way from the infinity at the straight line to the specific value of the radius of a circular curve to help the and to provide the gradual increase of the superelevation starting from 0 at the straight line to the desired superelevation in the circular curve. To ensure the gradual increase or decrease of the centrifugal force, the vehicle should negotiate curve smoothly. To introduce a extra widening gradually and to provide the comfort to the drivers and to prevent the possibility of overturning of vehicles on horizontal curve and to improve the design speed and reduce wear and tear of rail sections. Properties of transition curves. The first property is rate of change of superelevation must be equal to the curve and the radius of transition curve at junction should equal to circular curve must meet the circular curve tangentially. The length of transition curve is inversely proportional to the radius. Types of transition curve are spiral or clothoid, cubic parabola and lemniscate. Spiral or clothoid ideal transition curve or the rate of change of centrifugal acceleration is consistent. The radius of transition curve is infinity at the straight edge and the changes to r at the curve point and the calculation and field implementation is very easy. It satisfies both the rate of change and the center of acceleration is constant. The length of transition curve is calculated. Range of centrifugal acceleration is calculated by using Ls is equal to V3 divided by Cr, where Ls is equal to 0.0215 V3 divided by Cr, where C is equal to 80 divided by 75 plus V into m by second cube, which means 0.5 less than C less than 0.8, which is for centrifugal accelerations. Shift and length. The shift and length is nothing but the when the vehicle goes to this way, it does not provide any discomfort to the vehicles and also to the passengers. Super elevation. The inward transverse inclination provided to the cross section at the carriageway at horizontal curved portion of a road is called super elevation. In other words, the raising of an outer edge is also denoted in as a superelevation. This image shows how this outward edge is projected and it provides it does not provide any discomfort to the passengers and also to the vehicles. Objectives of providing superelevation to counteract the effect of centrifugal force acting on the moving vehicle and to pull the same outward on a horizontal curve, to help a fast moving vehicle and to negotiate the curved path without overturning or skidding. When we are providing a super elevation, the fast moving vehicle should not overturn or skidding and to ensure the safety of the fast moving vehicle and to prevent the damaging effect of the vehicle surface due to improper distribution. It permits advantages of providing a super elevation. It permits running of the vehicle at high speed on a curved path or a straight path without any danger of overturning and it results to the increased volume of traffic. It also keeps the vehicle to their proper side of pavement and prevents collision of vehicles on a curved portion of the road. It provides drainage of the whole width of the road towards the inner side and the necessity of providing on the side is highly important by providing a super elevation. Here the super elevation is highly explained. Now the vehicle is turning towards the outerward curved path, which means here we are giving the outward path, which is the super elevation, by providing the normal breadth to the certain height of outward edge, which is known as super elevation. This is For super elevation formula, where this one is for outer word and this one is circular curve, and this one is transition curve, and this one is transition curve, and here the apex is the super elevation point. Super elevation formula, theta 1 is equal to theta 2, where tan theta 1 is equal to tan theta 2. H by B is equal to P by W, and H by B is equal to mv square divided by R, which means mg. H by B is equal to V square divided by GR, where H is equal to BV square divided by GR. Super elevation formula, H is equal to BV square divided by GR. Here the sample calculation is given by using a problem. In this problem, calculate super elevation for a circular road having radius of 300 meters and it is 8 meters wide. Take 500 km per hour as a speed of vehicle and take centrifugal ratio as 1 by 10. Here we know the super elevation formula is H is equal to V square divided by GR, where H is equal to 8 into 13.89 square, which means we are calculating that 13.89 square is from V, where V is equal to given speed into, we are changing into meter per second. We get the answer as 13.89 meter per second. By substituting this, we get the answer as 52.5 centimeter. The rate of elevation, super elevation for plain and rolling terrains 1 in 150, for built up areas 1 in 100, for hilly and steep terrains 1 in 60. By studying this unit, we can observe the cross-sectional elements of highway and analyze and design horizontal alignment elements, identify and explain the components of pavement structure, and determining the side distance and vertical alignment of elements.